Hey guys, welcome to our YouTube channel. In this video, we are going to learn how to create a virtual environment in Google Colab. So, without wasting your precious time, let's get started. The first and the foremost step of this code is to check if Python is already installed on your system or not. This line is a command that checks the location of the Python executable. By running this command, you can verify if Python is installed and determine its location. This line of the code displays the version of Python installed, giving you information about the specific Python version that the Google Colab already have. Here we will set the Python path environment variable to an empty value, ensuring that Python won't search for modules or packages in additional directories. This step is often done at the beginning of a code block or notebook cell to start with a clean environment, without any additional directories affecting module import behavior. It helps avoid conflicts or unintended module loading that could arise from having previous directories in the Python path variable. It helps create a clean environment for the upcoming steps. Now for installing a virtual environment package, we will write pip install virtual env. This allows you to create isolated Python environments for different projects, keeping their dependencies separate. Think of it as a way to have separate Python setups for different projects. Here we will create a new virtual environment named myenv using the virtual env package. This environment will have its own Python installations and packages. It will serve as a contained space where you can install specific packages and work on a particular project without interfering with other Python installations. Now here, this command is a way to execute a shell command directly within the notebook. It allows you to download files from the internet using the wget utility. In this line of the code, the wget command is used to download the Miniconda installer file from a specific URL. This utility retrieves the file from the provided URL and saves it to the current directory in the notebook. So when you see this command in Google Colab, it indicates that the notebook is executing a shell command to download a file from the internet. In this line, it makes the downloaded Miniconda installer script executable, allowing you to run it in the next step. Now here in this line, it runs the Miniconda installer and installs Miniconda to this directory. Miniconda provides a way to manage different versions of Python and packages. Here we can see that we have written B, F, and P. Now, what does they actually mean? This option runs the installer in batch mode, which means that it runs without user interaction or prompts. It allows the installation to proceed automatically without requiring manual input. This option forces the installation to proceed even if a previous installation exists or if there are conflicting files. It ensures that the installation continues without being halted by any warnings or conflicts. And this option specifies the installation prefix, that is, the directory where Miniconda will be installed. In this case, it sets the installation directory to this one. It actually provides the directory where Miniconda will be installed. By using these options, the installation of Miniconda can be automated and run without any user intervention, allowing you for a smooth and uninterrupted installation process in the specified directory. Now here in this particular line, we have used JSON package. This is a Python library that provides fast and efficient JSON encoding and decoding functionality. It is an alternative implementation of the standard JSON module but with improved performance. The conda install command is used to install the UJSON package within the Miniconda environment. This option makes the installation process quiet without displaying unnecessary output. And this option automatically confirms the installation without asking for user confirmation. The purpose of installing the UJSON package is to have a faster JSON processing library within the Miniconda environment. When working with large JSON data, using UJSON instead of the standard JSON module can provide significant performance improvements. It allows for faster serialization and deserialization of JSON data, making it useful in scenarios where JSON processing speed is crucial, such as in high throughput data processing applications or large scale data analysis tasks. These lines import the sys module, which allows you to interact with system specific parameters and functions. It is used to access the sys.path attribute, which is a list that specifies the search path for modules. By default, sys.path contains locations where Python looks for modules when importing them. This particular line appends a specific directory, this one, to the sys.path list. This directory is the location where the Python packages installed within the Miniconda environment are stored. By adding this directory to sys.path, we ensure that Python can find and import packages installed in the Miniconda environment. It allows us to use the packages installed within that environment without any import errors. Now here we will import the OS module, which provides a way to interact with the operating system. This line sets the conda prefix environment variable to this directory, which effectively activates the Miniconda environment we created earlier and making it the active Python environment for subsequent code execution. Now, this line checks and displays the version of Python within the activated Miniconda environment, confirming that Python 3.8 is successfully installed and being used in the current environment. Now, by executing this line, you can see that the Python 3.8 has been successfully installed on your Google Colab. Because I have mentioned here in this line that I need Python 3.8 in my Google Colab. So by following all these steps and all these commands, you can install a particular Python version of your own choice. So congratulations, you have successfully set up a virtual environment using Miniconda and installed Python 3.8 within it. Virtual environments are, you can say, like separate rooms where you can have different Python setups for different projects. They help keep things organized and prevent conflicts between packages. Now you are ready to start coding in your isolated environment. Have fun exploring and experimenting with Python. See you in the next video.